video, we're going to be looking at the week 6 application questions. So the first one says, when a person first contracts a virus, the viral load can be as high as 2,345 copies per milliliter of blood. What is this number in scientific notation? So let's write this number out a little larger here. And what scientific notation does is it keeps us from writing a whole bunch of zeros, for one. And second of all, it makes our numbers a little bit prettier and more concise when we're working with them, especially either really small or really large numbers. So for scientific notation to work, the first number must be between 1 and 10. So if we look at this number here, where would the decimal have to go for our number to be between 1 and 10? Well, when we look here, if we put the decimal between the 2 and the 3, we have the number 2.345, and it would have to go there for the number to be between 1 and 10. So, from there, how many spaces should we move the decimal in order to get the number that it actually is? Well, let's count. 1, 2, 3, 4, 5, 6. So times 10 to the 6th. That's super easy. 2.345 times 10 to the 6th. A study finds that approximately 1,879,000 have the gene for green eyes. Express this number in scientific notation. Same thing. We're going to do exactly what we just did. So I'll rewrite this here. So where would the decimal have to go for a number to be between 1 and 10? It would need to go right here. So that leaves us with 1.879 times 10 to the... Okay, so let's figure out how many times we need to move this decimal to get the number to what it actually is. So let's do our little jumps here. And I always find it helpful if you actually write these out, just to give you a little bit of a visual. So 1, 2, 3, 4, 5, 6. So we've got 1.879 times 10 to the 6th. A solution contains 1.58 times 10 to the negative 5 milligrams of drug per milliliter. The client requires a dose containing 5.53 times 10 to the 3rd milligrams. How many milliliters should be administered to the client? Hint, divide the dose by the solution concentration. Okay, I like it when they give us hints. Alright, so first, if we're going to divide, let's find the dosage. Well, here's the dosage that they received, the 5.53. So let's take that and write that out first. 5.53 times 10 to the 3rd milligrams divided by the solution concentration. So that's going to be this number here. 1.58 times 10 to the negative 5. And this one, the units of this one are going to be in milligrams per milliliter. Okay, and that's perfect because our answer is going to be in milliliters, and when we divide, our units will actually get flipped, meaning we'll have milligrams times milliliters over milligrams. And the milligrams will cancel out and leave us with milliliters, which is exactly what they want. So, and when we divide these numbers, we're going to get 3.50 times 10 to the 8th milliliters. And if you don't know what to round your first number by or to, you can look at the numbers that they provide you in the question. So here they rounded to 2 decimal places, and here they also rounded to 2 decimal places. So it's safe to say we can round our answer to 2 decimal places as well. Okay, Write 2.5 times 10 to the negative 8 as a decimal. Okay, so now we're working backwards from the previous problems. So let's start with 2.5. And times 10 to the negative 8 means our number is going to get smaller. So we're going to move our decimal 8 spaces to the left. So let's go. 1, 2, 3, 4, 5, 6, 7, 8. Decimal is going to go right here. And all these spaces get a 0. So let's write this a little neater. We've got looks like 7 zeros here. 1, 2, 3, 4, 5, 6, 7, 2, 5. I hope this was helpful for you guys, and I will see you in the next video.